Okay, good. We are live. Thank you very much for being there. First time at the Skiff. Tonight I speak as Transferwise person. So let me adjust this microphone. Okay, maybe better in this way. Okay, so we had to change the topic, unfortunately. So we will recover the next one at the next meetup, probably by the end of March, by the end of February. So we can still keep the monthly organization, the monthly schedule. So what we are talking about tonight is a project I took care when I started in Transferwise. Oh, quick question. Do you know Transferwise? What it is? Yes?
Yes.
Are you a customer?
I will be soon, actually.
Oh,
Yeah.
cool. Very, very good. We are a fintech. We move money across different currencies. It's a quite new system. It works very well, and customers are very happy with us. So we are improving and improving things. One of the things are data, because everything is based on data. But we are not talking about the live systems. I will do it. I will work on the moving MySQL to Postgres, but it's not this the case. This is the first the very first work I did for Transferwise. So. This is not working. Probably because there's no focus on there. Yes, much better. So yeah, who I am. This is very simple. I look younger. Born in 1972. I started working with the IT in 1982. 10 years. I joined the Oracle Secret Society in 2004. Moved into Postgres in 2006, and yes, I'm in PostgreSQL, and I am data engineer at Transferwise. What is a data engineer? Everything and nothing. I take care of the physical aspect, the logical aspect, but in Transferwise we are very independent. So I just keep to connect things and make things work properly. So table of contents. I split it in six topics, six macro topics. Some history, what I found. Meanwhile, what the solution we considered for improving our situation, how we did it, and we are still doing. Possibly next week we'll go live the entire thing. We had some slight delay. The lesson learned in the scaling up using Postgres, which is not simple moving from MySQL to Postgres, and is even more difficult because we will see what we are doing and the wrap up what we're doing about this thing. So we have an appointment in London. We are 30,000 years late. I love Doctor Who. In particular, I love the fourth Doctor. So I try to stick any possible quote. So what happened in July? I changed the job. I moved from a company in Brighton to this bigger company. We have different offices, but I sit in London. But sometimes I work. Often I work thanks to Southern Rail. I work from home. So initially it was quite nice because they said, okay, let's start with something not customer facing. Let's have a look about this analytics database. And very critical. What was the problem? We have currently a MySQL database used for business intelligence. And despite the size is not exactly big, we will see the sizing later, but and the resources assigned are very, very big. Struggle at any time. Yes, we are using virtualization, but that's not the point. The entire system simply didn't scale. The data set it was medium size, about 500 gigabytes, not bigger than that. So struggling massively. So I did some tactical assessment. So the database is a simple. Ooh, oh, nice. It doesn't reflect the laser. So, okay. So the database is currently in 5.6 on InnoDB. We cannot afford to stay on MySQL. The buffer size is 60 gigabytes, the InnoDB buffer size. The total memory is 70 gigabytes. 20 CPU assigned to the virtual machine, 600 gigabytes on disk. Looker and Tableau, okay. Have you ever worked with Looker on Tableau? Very lucky, guys. Unfortunately, this software, they are analytic software. They are multi-database. It means can connect on everything, perform good on nothing. So they are particular. They write not optimized queries. Several schemas inside the database imported from a different microservice database, and one single schema replicated in real time from the live database using the MySQL replication protocol. One schema is used for obfuscating the personal identification data because we cannot expose this sort of information to anybody except controlled people. Because we can expose, because anybody can connect on Looker and run queries. If they get personal data, is not nice. So we obfuscate this data. I call this thing like the frog effect. You drop a frog into boiling water, the frog jump out because he feels the pain. If you put into a cold water pot and then turn on the gas, the frog doesn't realize it's being slowly boiled alive. And that's the case of the database. The entire thing slowly worsened. This thing has been put in place for solving an immediate problem, small data set. Then the company scaled out, the data set increased massively, and this is the situation. Data size increased over 2 years. The optimizer in MySQL, when you use the views, MySQL, when there's too much data, MySQL materialize the information, materialize the view, query what you need, and then discards the materialization. So I found some queries performing very well, milliseconds, accessed by a view. It takes 50 seconds, minutes. It depends by the size. So under normal load, the database just worked bad. Over busy periods, it became completely unusable. So new solution needed, and that was the my initial period, eye of the storm. So no good fit, obviously, but we needed some situation, some specific requirements because people were used to access live data in real time. The first requirement it was this one. The new solution it had to be replicated in real time from the existing live database. Data obfuscated for the analysts. That was simple. This is simple as achievement. PII available for power users because some users need to access these these delicate informations. And the system should scale for several years because for more time, the analysts spend a lot of time optimizing every 2 or 3 months on MySQL, and that was not acceptable because they were busy for building up, for optimizing rather writing new queries. And more important, the last in the order of importance, but for me is the first one, using modern SQL, because the MySQL SQL is not exactly modern. It lacks a lot of things. I think the latest version 8 added finally the CTE, but we're still waiting. It's still catching up on the modernness of the SQL. So when I arrived, I got 4 possibilities. Google BigQuery, Amazon Redshift, Snowflake, and Postgres. The first two, BigQuery and Redshift, were removed. Hello, welcome. So yes, the BigQuery and Redshift were removed for several reasons. Lack of flexibility, too much optimized for data warehousing. The cost, Redshift is cheap to set up, very expensive to run. So we foreseen some big bills coming in with Redshift. So we had these two candidates, Postgres and Snowflake. Both systems had a very interesting modernness, but neither of them gave us the real-time replication. So, little word about Snowflake. Initially, it was the candidate for being used instead of Postgres. Is a cloud-based data system, data warehouse system based on Amazon S3. So uses MySQL. You can load your data and query in a very efficient way because it parallelizes the queries across the even as the smallest machine worked very well with our data set. So it was an interesting thing. The outperformed Postgres. Seconds versus milliseconds. Obviously, Postgres single test machine, not exactly performant, versus the cloud-based parallel processing. It was, in my opinion, an unfair comparison because Postgres can scale out if it's correctly set up and they have resources. But yeah, apparently the winner will be Snowflake. The problem was how do we replicate the data into this Snowflake thing? And that comes the Fivetran technology, which is a pipeline which can read from any data source and stream into another different data source. Very interesting, very efficient, with an initial copy based on the same approach of MySQL in this case, with just one little catch: no obfuscation for this data. And because in Transferwise, our policy forbid us to move personal identification data outside our perimeter, we simply could not allow this thing. So the solution, the hypothetical solution, it was okay. Let's take this MySQL, copy into a different system because MySQL obfuscation in any case it doesn't work very well. So let's move this thing into Postgres, obfuscate the data into Postgres, and pull out the data from Postgres. So the idea was why not using directly Postgres for our needs and save some money in Fivetran and Snowflake after all. So and that was my DBA. It's like the spider sense. I feel when something is happening, and usually I do something in advance before having people to ask me. So I foresee this requirement. So I resurrected my old project called PG Chameleon, which was started in 2013. It was an experiment for moving the data. I presented the last Meetup, this project. It's a simple Python system which can pull out the data from MySQL to Postgres. So it creates a complete migration, but also can read from the MySQL streaming protocol and replicate the data into Postgres. So you can replicate from MySQL to Postgres with just one single Python program in the middle. So I optimized this thing. I made some tests. I made a minimal viable product. And with minimal changes, I've also added the obfuscation at initial copy. And on the fly, meanwhile, is replicating the data. So in this scenario, the initial scenario is what I described before. So pulling out the data, putting into Postgres, pulling out this obfuscated data into Snowflake. But at this point, Postgres it proved to be very efficient. So let's have a go for Postgres. And because Postgres SQL is very, possibly is one of the most respectful for the ANSI standard, any movement into a different more ANSI system, it will work much better than moving from MySQL. So we set up this thing, and before going further, I will describe quickly how it works, the MySQL replica, and how it works the PG chameleon / PG obfuscator. This is an internal project which at the moment is not open source. Maybe one day we can do it if somebody thinks it can be useful, but is easily adapted for our needs. But in any case, all the concept inside the replication and initial copy is exactly the same in PG Chameleon, and is the tool is released under the too close FreeBSD license. Is available on GitHub. So if you want to use it and play it, I released recently the Alpha 2, but I'm ready for adding the Alpha 3. This week I worked a lot on the 3. This is the PG Chameleon is a commute project. I work with meanwhile I'm traveling. So how it works with MySQL Replica? Difference with Postgres, at least up to the version 9.3. MySQL is logical, Postgres is physical. When it's configured properly, it means setting up the log bin variable and enabling the log bin format. MySQL logs any data change into local binary logs. The local binary logs are accessed by the slave. These changes are pulled out into the slave. The slave saves into the local relay logs. This is a simple schema. And then a different thread read from the relay logs and replay the changes into MySQL. Very simple. So it's a four channel movement of data. It's very important to understand that these data are just binary encoded, but they can be raw images, queries, or mixed raw images and queries, because MySQL supports different format of logging. In this thing, it comes the PG Chameleon, which is the lovely guy. The logo is a nice chameleon with a Python scarf called Digor, and it does exactly the same. The difference is pulls out the data from the master, transforms this information into JSON-B data, and the PLPGSQL function decodes this JSON-B and replay the changes into Postgres. With an extra nice feature, initializes the replication with just one single command. Init replica, it will do all the steps for the MySQL initialization with all the bad that this can represent. So this is the schema. So we have the MySQL master is still logging into the MySQL bin. PG Chameleon reads the raw images, decodes the data, stores into the JSON-B field, and then the function replays this thing into Postgres. It's very important to understand how the different binary logs can affect this thing, because the default, as far as I remember, there's different. It depends which minor version is in MySQL, but it was statement initially the default format. Now they switch to row for reasons, but the idea is the mixed format is the best. What's the difference? If you set the statement format for the logging, MySQL logs the SQL statement. So update table, blah, 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 set value to blah, blah, blah. This is not possible to be used because it means converting the dialect, the MySQL dialect, into the Postgres of whatever dialect. The PG Chameleon uses a specific library called PY MySQL Replica. And yes, you can read the statements, but moving it across different data sources is complicated. Raw format, and there's another problem with the statement, is not deterministic. If for some reason your updates are using UUID inside the update, you're getting different values on the master and slave, so complete inconsistency. The raw format logs the raw image, and this is the format required for the replica working. You get the exact values, completely undeterministic, completely deterministic, but is not exactly performant in MySQL. So they suggest to use the mixed. How does it work? It logs the statements. If the database feels that you are using a not deterministic function, falls back on row. So sometimes you get row, sometimes you get statement, and then in this case, it's not good for our replica, for our tool. So how we did it with maximum effort. Another guy, I really love it. So using the chameleon, I built up this thing working, forked it into the Transferwise repository, GitHub repository, and with other things for working, for having the obfuscation on the copy and in real time. The cascading replica, because we are taking the best, so our master is working in mixed way, we could not use the master directly. So MySQL supports a very interesting thing. It can be configured in cascading replica. So you can have a master, a slave, and this slave can be configured to log the query pull from the master in whatever format we want. So the master sends the queries to the slave logs the raw images. And there it comes, the PG obfuscator, so pulls out the data in the correct format. This is required even for another reason. The initial copy locks the tables in read-only mode. This is the MySQL procedure for taking an initial snapshot when you pulling out the data. So it's not acceptable having a several hours read-only database online. It means bringing down the business. So we set up this MySQL master, replicated into MySQL slave, and the slave data is copied and obfuscated using into a Postgres database. You can clap now. So let's move through the replica initialization. I mentioned the lockdown, the table lockdown. It's very simple. If you read on the MySQL manual, you will get this information. Flush table with red lock, and the session it must be connected. As soon as the connection disconnects, the tables are unlocked. So you need one session doing this single job. Get the master coordinates. The master coordinates is the bin log file name plus the byte position inside the bin log file. So it means from which position inside the binary log start streaming for the replica. Copy all the data, release the log. Very simple. So how to copy this thing? Yes, this is one part of the query. Because the fastest way to load data into Postgres is using the copy command, which is single transaction, no parsing at all, very, 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 very fast. I use this query to build up a select list to be fed into a MySQL query to pull out the data in CSV format. It does a very interesting thing. If the data is enum type, it splits the enum list, and the enum list is used for building the enum type into Postgres. If the data type is inside a specific set of values, binary, so blob, clob is Oracle, blob, large lob, something like this. The data is exified on the fly. In this way, it's very simple to load into the byte data type. There's no character conflict. Otherwise, there will be massive issues with the UTF-8. Yeah, I feel your pain. So it builds up the X, and if the data type is a bit, uses another strategy. So it generates this list of select that is fed into another select to MySQL for pulling out the data. This is quite common in the Oracle world. Running a select for building out another select, pulling out the data, and then using another select again to load the data into the database. It's quite crazy. 90% of the Oracle universe works in this way. I can testimony because I've been in that universe. In this part, I removed a part of the query. This is not in this way. If you are curious, is available on the GitHub repository. There's another part. Because the copy is single transaction, if for some reason the load fails, I'm losing the entire batch. So I've added a fallback procedure. If for some reason the load fails, the system falls back on single inserts. So only the problematic queries are, the problematic rows are discarded. But there's one catch, it's very slow. One load for 1 million rows with the copy can take 10 seconds. With the single insert, it can take 30 minutes. So the system allows different slice size to pull out the data and load in small batch for two reasons. If you are loading, if you are downloading a 20 million rows table, the memory will be not sufficient. So it splits the table in small slices, download and reload, download and reload. When it drops the error, it falls back on the inserts. And it works pretty well. The obfuscation is using another different approach. The rule of thumb with databases is the fastest way to move data from inside the same database is using the select insert. So first the load happens into the data not obfuscated, and then there's a very clever query which obfuscated the data using SHA-256 using the extension pgcrypt. So the same obfuscated tables listed into a separate file, YAML file, for specifying the different obfuscation strategies, is copied after the load is finished. So it's incredibly quick compared to the rest of the procedure. So the data is copied into the schema in clear. Then the table locks are released. The first thing happens after the load is finished, the locks are released. So the slave can catch up with the master. And there's no real need for keeping up the locks more than required. The tables are copied into the obfuscated schema, obfuscating on the fly the data. The process then builds the indices, and all the tables without the PII are just exposed as views to the obfuscated schema. And thanks to the very strong Postgres security model, all this data, all these views can leave the people access other schema tables without having real access on this schema. So if the user which does this operation grants the access to the separate schema, the tables can read from different schema owned by the same user without the need for accessing the direct tables. It's very interesting. Sometimes it's annoying, but the Postgres is very paranoid about security. And yes, there's the one last step. All the varchar fields are converted in text fields. We will see the reason why later. So this is the initial part. So take the copy, build up an exact replica of MySQL into Postgres, and obfuscation on the fly. All the data changes on the live database has to be obfuscated in the same way into Postgres. So the process is very simple. Having this YAML file which describes the tables with the obfuscated data, when the raw image comes in, the system catch up if the row is part of an obfuscated table or not. In this case, generates another raw image with the obfuscated data, and rewrites the destination schema into another schema. The dictionary, the JSON-B, it carries all the information. So which schema it has to be written, this information, it has to be replayed, this information, the row idea, and there's also all the primary keys attached to the key, to the table. There's still the same catch with PG Chameleon. Only tables with primary key can be replicated in this system. And so the PLBGSQL function, it doesn't need anything. I literally not change nothing in the replay function because everything was inside the logic of the database. And I was impressed how it worked. So JSON-B works very well, very performant. And even when I have days of lag, because sometimes the replica breaks down because I have to tune several times this thing to work properly over the weekend. So I can have 2 days lag compared to the MySQL slave. It catches up in less than 12 hours to the system. So I can't believe how he's working. The reason why he's working so well. But yes, it's nice. It's nice to learn. Oh yes, the DDL replica. When the what happens when somebody alter a table? So add a new column, rename a column, or so on. Add the new tables and so on. This is the difference with PG Chameleon. At that time, I had no experience with the regular expressions. I took the occasion to learn about the regular expressions, so to get two problems instead of one. So to solve in a quick way, not elegant, but very efficient, is this way. There's a simple regular expression catching the DDL, because the DDL are still logged as statement when they come in, even if is in raw format. This information is extracted. So I just get the table name and the action. When I get this information, I query the information schema on MySQL, get the table's metadata, and rebuild the exact table into Postgres, or get the field metadata and get the new field into Postgres. So it's not elegant because I'm working on PG Chameleon to have the regular expression working, and they're working pretty well at the moment, but they are not completely tested. So better not elegant, but working. And this thing has broken down possibly 6 times since I put in replica, and from September possibly. So crazy things like rename and modify. This is still the change and modify is still not supported, but I solved the issue, and possibly this weekend I will port down this thing. On PG Chameleon is already working. I did the commit this morning from the so it's a pain in the back because there's different languages, but has been solved. So let's see how this thing performs different systems. The master procedure is our procedure which aggregates data, pre-aggregates data for being quickly consulted by the analytics tools. On MySQL, 20 hours, constantly increasing every day with all the resources assigned. On Postgres, 4 hours, and it's still being optimized. So day by day, it's becoming faster and faster. So we have this master procedure run each weekend, plus incremental procedures. On Postgres, we can do this thing every day and get the entire bunch of data reaggregated quickly. These two queries are queries for the analysts. So extracting the IBANs shared across the users, and extracting the notification from our provider for payment ADN. There's a slight difference. In MySQL, the first query didn't complete. After 25 minutes still running, I decided to kill it because it was taking too long. No idea how long, probably hours. On Postgres, not cached 3 minutes, and on Postgres cached 1 minute. The second one, on MySQL, just 6 minutes. On Postgres, with the empty cache, 2 minutes. With the table cached in memory, 6 seconds. What's the difference? This table, this query, access a relatively small table with a lot of aggregation in memory inside the select list. The second query accesses a very large table. I think it's about 30 gigabytes, about 40 million rows probably. So in this case, the computational over the aggregation made MySQL perform very, very poor. Postgres, cached or not, yes, it's 3 times faster, but not exactly big difference. It means, okay, it takes 2 minutes to scan the table and then 1 minute for aggregating data. This one is a large table, so a complete full table scan. Initial table scan, very good in MySQL, 6 minutes. Postgres slightly faster, but once it's cached, you get the data directly because Postgres is much more efficient in caching the blocks rather MySQL. Resource comparison. This is the part I love. I love most of this presentation. The storage size between MySQL and Postgres is different. It's more compact because Postgres, using the toast strategy, can compress some part of the data. The CPU, the server CPU on MySQL, I had to borrow some CPUs to assign to the new machine, but we are talking about 10 CPU less, performs much better. Server memory, 68, 48 gig, even slightly lesser. But the interesting part is shared memory. Postgres is using just 5 gigabytes. So it means I can assign more per user memory to improve the sort procedures, the aggregation, and so the work memory. MySQL is using, the memory is used mostly by the InnoDB shared buffer, the InnoDB buffer. Max connection, 500, 100. I will increase probably to 500 once it reaches the production state, but I can also use PG Bouncer on Postgres, which is very, very efficient to do the connection pooling. So possibly I don't need all these connections. I just need to optimize the way that the people connect to the system. Other advantages using Postgres. Stronger security model. Sometimes very, 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 let me stress this, annoying. In Postgres, you cannot grant the drop privilege. If you create your A table, I cannot drop it unless I am super user. There's some workarounds. The permission work per schema. So if you create a schema owned by a user group and assign all the users to this user group, you can let the user drop each other tables, which is quite useful having different developers working on the same schema. But it took some time to understand the correct approach for this thing. And yes, it was having people, it was reasonable an annoyance because it slowed down their work. But now we found the solution. Better resource optimization. See previous slide. We can assign more and more resources and get more scale out to the entire system. Oh, no invalid views. That's something I really like it. If in MySQL you have a view referencing different tables, and you drop one of these tables, the view is still there. It cannot be dumped out. So you have to skip the view when you back up your database. In Postgres, everything has to be valid. The dependency model is crazy as logic. It took me possibly 3 days to understand how the PG depend works, but is incredibly robust. If you try to drop a table referenced by a view, you cannot do it. You have to do using the cascade. Obviously, with the cascade, you can drop half of the database, but that's not the point. No performance issues with the views. A view in Postgres is just a logical query. And from that logical query, the execution plan is generated like you are running the query inside the PSQL client or the PG admin client. Complex analytic functions. We have CTE, window functions, different aggregation systems. The 9.5 added the very interesting data warehousing functions for analytics, where you can filter and reaggregate using the aggregate functions. But I'm looking forward to move to Postgres 9.6. I didn't write wrote it there, but Postgres 9.6 adds some parallel execution functions. So it's possible to have different workers pulling out the data and improve the performance even better. Partitioning. We partition a very huge table using PG Pacman with a better index optimization, better storage optimization, better performance. Tables not used because too huge into the MySQL system are not being used for our analytics. So it's a massive improvement. And this last guy, brain indices. It was my first time using the brain indices. Thanks to who invented this thing. The brain indices are block range indexes. They index just the range of blocks where the data is for sure present. So they are lossy, but they can index a 30 gigabyte table in just 256 kilobytes and do not bloat. So having this thing, these indices are introduced for big data. So large tables can be indexed without all the problems associated with the B3, the traditional B3. Obviously, you have to rescan the table for getting the data, but a full index scan over a large table can be very problematic. And this is a quote for our growth analyst, data guru, the man behind the project for moving from MySQL to Postgres. Is coordinating all the efforts. So some code has been optimized, but very little. We still need to work over the execution plans. And the timing with my the performance increase, it was just MySQL to Postgres. So it's just a more efficient engine in Postgres. I didn't wrote in this presentation, but yesterday I gave access to a analyst, and he started yelling because a query in Tableau taking 5 minutes in Postgres, it was instantaneous with the same data set. So he literally jumped out of the seat and said, "Wow, that's fantastic!" And this is great improvement. So lesson learned in moving this thing. This is the Phantom playground. This is a picture I took probably 10 years ago in a very foggy night, not in Brighton, in near Florence. Um, yes, the initial copy didn't work. I was at the PostgreSConf in Estonia when initially I launched it. I started the initial copy on the real live dataset. Didn't work. After 3 hours, OM killer get rid of Python process. So there was some tables used as file system. It's quite common to find these tables with XML documents or JSON documents, several kilobytes of data stored into one text field. So these tables simply exhausted completely the memory and simply didn't work. So I had to optimize per table, the slide size, so trying to find out the optimal number of rows to be pulled. But there was another thing. Initially I was very conservative. I ran a select count, slice the numbers, and split in single slices. So I had a table which took just for running the select count of MySQL about 8 hours. Yes. So, not good. So in this case, I fall back on the information schema. So using the information schema, I have some statistics about tables. So I can get the estimated number of rows, but meanwhile, it depends by the engine. If you are using InnoDB, this information is the exact number of rows. If you are using InnoDB, sorry, on MyISM, you get the exact number of rows. On InnoDB, you get just an estimate. So relying on this thing, it wasn't possible. So I use this information just to have some meter indicator, progress indicator, meanwhile the copy. But at this point, I have some tables copied by 90%, 95%, 103%, 110%, and so on. So the system just pulls out the data when the data is no longer available because it sliced by using limit and offset. This info, it stops with the table and move to the next table available. So yes, the output can be quite odd. And even using the because I'm using py MySQL, a pure Python implementation for the connector to MySQL. I took advantage of the not unbuffered cursors to have a better memory optimization. The unbuffered cursor, it just pulls out the data without buffering anything. Otherwise, you will load in memory the entire dataset, and the OM killer will crash the project, the process again. So, however, even after fixing the memory issue, the initial copy took 6 days. No way. 6 days for pulling out 600 gigabytes of data. No way. No way at all. So working with unbuffered cursors, working with better estimates. Now the initial copy takes just 30 hours, including the time for rebuilding the indices. So in general, after 20 hours, the lots are released, and then the obfuscation index build starts. So when the initial copy is taken, it's just 30 hours lag, which is recovered usually in 6-7 hours. So in 36 hours, this analytics database can be rebuilt completely. Another interesting thing. Strictness is an illusion. MySQL doubly so. It's like the Hitchhiker's Guide to the Galaxy. Have you even tried to add a not null column to MySQL without specifying the default value?
You have fun all the time at work.
Yes, and it's fun because it doesn't throw error.
Yeah.
No, it just creates default values implicitly. So all the data is changed to default value, which depends by the data type. I think for integers is 0, datetime is the 9070, something like this, or all 00. I don't remember. It's written on the manual. But this causes big problems on Postgres because when this comes, is not logged. This implicit default is not logged. So Postgres expects not null value on the other side. But when he pulls in data, the value is stored without error in MySQL, implicitly converted, but the raw image pulls out null values. So Postgres replica fails. So solution, not nice. All the new columns added after the initial copy are always nullable in Postgres. In any case, this is something, we are not creating an exact replica of MySQL. We are just replicating data. Not even the indices are replicated because indices in MySQL have different meaning with Postgres, and it can be confusing for the optimizer. So the initial copy creates the same indices, but if new indexes are created in the original MySQL, they are not replicated into the Postgres database. Postgres have a different story. Oh, that's interesting. The string, that's the reason why all the obfuscated data are converted in text. The initial copy reveals the exact structure of the table into Postgres. So varchar 30, integer, big integer, and so on. But what if I fill these three character, varchar 3, and then is obfuscated using SHA-256? It creates a string of, how much is 16 characters or 30 characters. If you do this in MySQL, MySQL truncates the string, so it keeps just the first three characters. Does not throw error, in my opinion, corrupts data. Postgres throws the error. So using text, you can stick whatever you want inside, and you can obfuscate without risk of falling, making the replica to stop. Yes, I feel a lack of constraint disturbing. There's also a little problem. You can stick out of bound data without getting errors in MySQL. You can, I think, you can stick negative dates in MySQL. There's an interesting video about all these things. You can do division by 0, and instead of getting the error, you get 0. So it's quite complicated. So the system, when replays the data, try to trap the error. At moment, logs this information on the process log. The next step will be log this thing into a table. Already, PG Chameleon already does this. Exifies the JSON-B and stores the data in a safe place where people can check if this data is missing or whatever rubbish is inside. So yes, trying to keep the replica running despite the less strict on the other side. Unfortunately, Postgres has to follow. It has become less strict to interact with MySQL. So wrap up. We are almost there. It took us from the initial decision made in August 5 months to have a working product, and all the procedures, many procedures in SQL and Python migrated from the MySQL dialect to the Postgres dialect. Possibly the next week will go live. It has to be already live, but I found a little glitch in the obfuscation process, a nasty try except in Python, masking the problems in the obfuscation process. So missing rows in the obfuscated schema, which I already fixed, and I will fix probably by Friday. So I'm very keen to see this thing work. And yeah, the next step it will be staying on Postgres, improving this thing, migrating to Postgres 9.6 as soon as the next minor version comes out, and possibly taking advantage of all the things in the ecosystem. My mind comes to CitusDB. Last thing, we are hiring. If you want to have a look on our website, we have several jobs. For now, I'm just the only data engineer, but the work is increasing, so possibly in the future there will be more data engineers. And questions?
Yeah, at the start you mentioned that this solution had to run for a couple of years.
Mhm.
How have you determined that it will? Have you done some performance analysis beyond what you're currently doing to say, yes, when we've 4 times the data in our database, this will continue to work? It's just, I remember a speech you gave at a previous presentation where you detailed all the problems you had as you grew at a certain other company. So you have that kind of knowledge now.
Yes.
What gives you that confidence?
I'm pretty confident with Postgres because the optimizer is something very sophisticated. So increasing the data, it means changing the execution plans. I do not expect everything will be nice, but few queries will require maybe rewriting, or some data will need different approach, maybe repartitioning, maybe indexing, but nothing dramatic like the MySQL situation. Because
to maintain.
maintain, but we not many efforts, not reinventing the entire thing every 2 or 3 months. It means when something comes in and becomes complicated, address the problem, improve the speed, find a different solution, or moving to a more horizontal system. CitusDB is one of those. There's a case study published by CitusDB. Cloudflare is using this system for parallelizing the analytics query. I think they are indexing about 1 petabyte of data over thousands of different Postgres instances, and they are pulling out this user data. They're using all the usage data from their cloud system. Their CD is pulled into the system. So I'm pretty confident. If not Postgres single instance, there will be something else. There's also PostgreSQL. I remember Simon Ritz mentioned at to the last Postgres day in London. The aim is to merge this distributed code into the main system. At the moment is a fork, but in the future, hopefully, will be part of the core system. So we will have one consistent distributed database over different physical locations. I don't think it will be in the next year, but maybe in the new, if it's not the version 10, maybe version 12. They changed the version system. So fix your script. Yeah. They moved from 9, the 9.6 is the last of the 9. The next one will be 10, and the next after the 10 will be 11, and so on. So it's more, yeah, they removed a very controversial versioning system. To be honest, I love the old fashioned, because a major versioning means the change of the first number, it means dramatic changes. But I reckon that people do not live very well with this approach, and now Postgres, every new version is giving more and more things to absolutely cool things to and features to work with. So it makes perfect sense to have this different version.
And one other tiny question:
Mm-hmm.
You shard PII data. Why? So you can go backwards if you need to. You know,
we have people doing sensible researches which need to get this PII. Yes. Right, okay. So we have people investigating things, and they need to access the names. Let's put it this way. That's it. Thank you very much. And yeah, I will upload the slides in the usual place, and the video, hopefully, we're still broadcasting. It will be available possibly in the next couple of hours on the YouTube channel. I will share this thing on the Meetup. Sorry?
You already put the link up where it's going to be transferred?
Yes, for watching, but I'm not sure if it's the correct one. Anyway, thank you very much. Let me stop.